Here's another how to design functions problem. And again, it elaborates on the problem we saw before. What I'm going to do in this problem is when I start out, I'm not going to choose the best signature, and then we'll fix it later. And the reason I'm doing that is I want to illustrate to you that the how to design functions recipe is not intended to be what's called a waterfall process. It's not intended to be something that you do the first step, and then the second step, and then the third step, and absolutely get each step right. It happens pretty often that you go through the recipe, and you get to kind of the third or fourth step, and maybe you realize, oh, the signature is not exactly right, and you go back and fix it. And sometimes what even happens is you skip a first step to go to a later step just to get started. A common example is you're not quite sure about the signature, so you go write some examples, and then you come back and do the signature. Now what I don't want to do is give you carte blanche to jump immediately to the function definition and do that. That's not going to be what we're going to call systematic design. But I also don't want you to feel like, gee, I just don't know what the signature is, but I'm not allowed to do anything else until I write it. There is some flexibility in following the steps of the process. It's a structured process, but it's not a locked-in waterfall process. So here we go. Let's do this example. In this problem, we're going to design a function called ImageArea that consumes an image and produces the area of that image. And it says for area, we just need to multiply the image's width by its height. So let's see, this function consumes an image, and it produces the area of the image. Now, you might think this should be number, and that's actually going to turn out not to be right. But I'm going to go ahead and pretend that I put number for now. Because one of the things I want to show is that sometimes you realize partway through the process that a piece of what you did before isn't right. So I'm just going to put number for now. And I'm going to say produce images width times height, or area. And let's see, the stub is going to be define image area. And I like to abbreviate image to IMG, and a good dummy value is 0 because it's a number. And now let's do some examples. Check, expect, image area of, let's say I have a rectangle that's 2 wide and 3 high and that it's just red. Well, what's the area of that? Well, the area of that is times 2, 3. All right, let's run that test to see if it's well formed. Uh-oh, rectangle is not defined. Oh, that's because whenever we use image functions, we need to tell Dr. Racket that we want to use the image function, and I forgot to do that. So we're going to say require to HTTP image. This is a very common mistake, and I made it here on purpose so that you would see it happen. You just forget to do the require. Now that we've done the require, the test is actually running and failing, but it's running, so we're doing reasonably well. Let's keep going here. Define image area. So that's the stub. We'll label it as that. We'll do the template, which will be ... img. Now we'll make a copy of the template. We'll comment out the original template and label it. And now what's this going to be? It's got to be the image's width. We're going to use image twice because we need its width and its height. So we're going to use image twice. We're going to say image width of the image and image height of the image. And we're going to multiply those two together. Now let's run that. And the test passed. But now we might realize this interesting thing, which is that images are always sized in pixels. And Pixels are always a natural number, 0, 1, 2, 3, 4, 5, something like that. You can't have 3.2 pixels. That's not how pixels are. So if the width is always going to be a natural and the height is always going to be a natural, and you multiply those two, this actually could be natural instead of number. And one of the things that we're going to talk about a lot in the course is that when you write the signature for a function, you always want to use the most specific types that are correct. Turns out it makes it much easier to think about using the function and to debug programs if you use the most specific correct type. So in this case, this function was never going to produce a floating point number like 3.2. It's always going to produce a natural, so we take the trouble to make the signature say that. I'll save that file and run it one last time. The test passed.